In this video, we are going to have a look inside DeWalt's DWB800 blower, and spoiler alert, I'm not too happy with what I see inside. How's it? And welcome back to the Burton Builds Garage. In today's episode, before we get to the teardown, we're just going to mention 4 of DeWalt's blowers. Firstly, this one, the DCBL772, is the corded version. You also get a battery version, the DCE100. It's the 20 volt max version, if you will. And you get the bigger boys, the DCBL722 and 772. I've put links in the description for those. Go check them out, check out their specs, read their user reviews. Now, the reason I bring these up is because this one specifically has got a cord. And while it's not super inconvenient to use, those battery versions are quite a lot more convenient to use. So if you've got a little bit of extra cash lying around, maybe pick one of those battery versions up. Yeah, let's get into the teardown. First thing we've got to do to take this unit apart is to remove the nozzle. So this is just a twist lock nozzle, and we can put it off just like that. And this clamshell is like a multi-part clamshell. So we've got a section over here, we've got an outer section, we've got a kind of a middle section here, and then we've got an outer section again on the right hand side that houses the motor. We've also got a small section along here which is fastened by 4 fasteners on the side, the right hand side, and that'll expose what's happening in the switch area. But to get started, I think we're going to take off this outer housing that houses the impeller, and to do that we need to remove these 4 Phillips head fasteners. Also, in case you guys didn't notice, inside here there's also a little clip in there and in there which we have to unclip. So fairly easy. Let's get those fasteners out. I think what we are going to need to get these little clips out, and that's these little guys in here, is just a flat screwdriver, and you pop it in there and you should just be able to lift this little tab up. Not the easiest thing to do, but there we go. Lift the little tab and there we go. The top of the clamshell comes off. So before we have a look at this section, let's have a look at the top of the clamshell. Now this device or this tool has been used quite a bit already in the testing, and of course in the video that you have already seen, so there is going to be some dirt around. So we can see it is a PA6 glass fiber reinforced 30%. As is with most of the DeWalt products, they are nylon products and with glass fiber reinforcing. This QF800, not exactly too sure what that means, so maybe if any of you guys know, let us know in the comments section below. The casing is fairly sturdy. If I try and flex it, it doesn't flex all that much. I mean, look, it does flex, but nowhere near as some of the other cheaper brands that I've seen in the past. I mean, this bit of plastic over here in the center is really nice and thick and solid. The other half of the clamshell is basically a carbon copy of the first half that we looked at. Biggest difference is that this half has got an impeller sticking in it, or out of it, should I say. As we can see, the impeller is it's like a plastic or probably a polycarbonate impeller, so not metal at all, and probably just an injection molded part. I must say it is very stiff and robust to the feel, you know, just squeezing it with my fingers. Although I'm definitely going to say that I think if this thing sucks up an 8 or a 10 millimeter bolt or a nut or something like that, there's a good chance that it might chip off one of these impeller fins. So just be careful of that when you are sucking up stuff. We'll definitely see over time. I've only had this thing a couple of weeks and been using it, and I don't really use it for sucking up stuff, only for blowing, as most of us will. So just keep that in mind depending on how you're going to use it. To get the impeller off, we've got what looks like a 6 millimeter bolt, number 10 socket, and that is fairly easy to do. We just loosen it up like that, and it's got a nylock nut on it, which is quite obvious for something that's turning and vibrating. Once we pop that nut off, this little impeller should just come right off. Looking closely at the pin, we can see that it is a completely floating pin, so no real friction fit there, and there's a little bit of a washer at the bottom. Now be careful when you obviously take your thing apart, your unit apart, that you don't lose this pin. And this pin is quite important because it secures the motor shaft onto the impeller. Now this impeller has got a little bit of a recess in there, and that pin drops into that recess. And we can see that the other half of the clamshell, of course, it's going to be made with the same material, also a PA6 glass fiber reinforced 30%. Again, this QF800, not exactly sure what that is. But to get this side of the clamshell off, we've got 4 fasteners, and it looks like you can use a flat or a Phillips head screwdriver. And now we can actually lift off this section of the clamshell, and the bearing is likely going to come out. There we go, as I thought it would come out. And don't lose your screws. Looking at the motor, we can see that it's got a bearing support on the one end. Now there's probably likely also going to be a bearing support on the other end, but on this end there's a 629 bearing, which is a 9mm shaft, a little bit bigger than a skateboard bearing, and it's just not even a press fit, it's just a slide-on fit onto the motor's shaft. So if we pull that off, and then we can actually see the complete motor. Now, of course, everything looks nice and clean and new inside here because this thing is fairly new, but I'm guessing that because of some of the cooling or some of the air that flows through here, eventually it's going to get quite dusty in here. As you can see, there's quite a lot of space between the motor and the casing, and there's going to be a lot of airflow through this section. Also, just guys, remember again, before you try and pull this armature out, take off the brushes. Taking out the brushes is fairly simple. So there's one on this side and one on the opposite side. All that we have to do is get a bit of a flat screwdriver, and we'll untwist this little cap, and that should loosen up and expose the brush. And there we go. We can see, oopsie, let's not lose that cap. And there's our brush, and it should come right out, just like that. So we'll take the other side out as well. Now, while I'm doing this, I had one of my viewers comment, and I think he was battling to get his, if I remember correctly, it would have been his angle grinder, and he was on one of the battery versions of the angle grinder, and it was a brushed version, of course, and he was battling to get the armature back in, and eventually he didn't realize that he was battling with the brushes. And it took me a while to get back to him, and in that time he actually figured it out for himself. And it's something very easy to miss, and a lot of us can miss that, especially if we don't work with these types of things very often. So a good thing to keep in mind. Now that the brushes are out, the armature should just pull straight out. And there we go, pulls right out, no problems at all. Having a close look at the armature, we can see that there's been a bit of grinding on it. Now this is likely to balance the whole armature to make sure that it spins nice and balanced, because it spins at about 16,000 RPM, or should I say up to 16,000 RPM. So pretty fast, and you can imagine if this thing is out of balance, it's really going to vibrate in your hand. So good to see that. Also very good to see is in here there is an epoxy, and that epoxy runs between here where the COM bars are, where the conductors join onto the COM bars, and that is all around. We've got that epoxy. Now that is put there because this is kind of a weak point with these types of motors. After vibration and after heating cycles getting hot and getting cold, the joints get a bit brittle, and sometimes you can have a break, and this bit of epoxy here just helps out with that. Well, it delays those types of failures. Also, if you guys know of any other reasons why they put the epoxy on here, definitely let us know in the comments. Looking at the bearing at the back of the motor, we can see it is a 627 RS, so 7mm shaft, a little bit smaller than the front, but no problems there. Feels quite nice and sturdy, and this one is definitely a solid press fit onto the back shaft of the motor. Next thing to do is going to be to expose this section of the clamshell. So we're going to turn our little unit, or half unit should I say, back around, and there's 4 Phillips head fasteners on the handle. Now, once those are removed, that should expose the speed control, the switch, and also the wire connection that'll enable us to remove those windings from the case. Now we can split the handle section and that's going to reveal, as I said, the switch, our speed control, and the wires that go into our windings of the motor. Having first look at the handle section, part of the clamshell, we can see, as expected, PA6 glass fiber reinforced 30%, so nylon material, and this should have a thermoplastic elastomer, a TPE marking somewhere, and that is this bit of rubber overmolding on the side. Otherwise, again, this part is obviously a little bit more flexible than the others, but still feels pretty sturdy, and it feels really strong, and it's not just going to break if you drop it. We can see the overmolding has got little ribs on it between the actual molding itself and the clamshell. There's a couple of them along here, and there's some small little pips that stick out into the actual clamshell. There's 1, 2, 3, 4, 5, 6 of them, and those are all going to aid in keeping this overmolding stuck to the clamshell for as long as possible. It would definitely come off if you didn't have a lot of these. Well, it'll come off a lot sooner than expected. The strain relief over here is quite neat. There's a bit of a rubber strain relief, and you can see there's 2 fasteners with a piece of plastic that is actually holding the wire in place, and looks fairly good. I must say, compared to, let's say, for example, the heat gun, this is not as beefy and as thick a wire as the heat gun, although this machine is only 800 watts and the heat gun was I think it was 16 or 1800 watts, so definitely good reason for it not being as thick. Moving up to the switch, we can see that it is a plastic switch, just like everything else that has a switch, and I like what I see here, where we've got fasteners with lugs onto the wires. I really am a big fan of that, although I do realize that in some places where there's a lot of vibration, these things can come loose. I would still rather have these types of connections. If we pull the switch out, looking at the top of the switch, we can see that it is a inning, well, at least that's what it looks like, TN14, and there's CQC markings. Looks like a 10 amp 250 volt switch, and that should be good enough for the power requirements of this machine. Feeling the switch, it's got a nice clicky feeling. There's definitely no dust protection for this unit, and this is the little locking mechanism. So overall feels very plasticky, not the best switch that I have felt in a DeWalt product before, but I guess it's going to do the job. Speed control part of the board, well, basically the only board that is in here, is not looking too great in my opinion. It really looks like a, I don't want to say a cheaply made board, but it's, it doesn't really have a conformal coating on it. If you look at the back here, it's really looking very dirty and nasty. Looks like, I don't know, this doesn't look like a professional product to me. Definitely not as good as some of the other DeWalt products I've seen. So other than that, the speed control is just this rotary potentiometer with it's probably got a click, well, not a click I should say, but a switch on the one end, and the bit that's controlling the speed is this little triac. Now this is just a standard triac, a BTA 16-800, which is an 800 watt 16 amp triac, and we can see that it's got a small heatsink on it. This heatsink again is quite a lot smaller than the heatsink that we saw on DeWalt's heat gun. Now, of course, that heat gun is doing pretty much double the wattage, double the power that this is doing, but at least there is a bit of a heat sink. And we can see that it hasn't been screwed on, it's actually just been riveted through over there, and it does look like there is a little bit of thermal paste on the back here, but overall I'm not very impressed with the condition or with the look of this board. To take the motor windings out, we need to remove these 2 Phillips head fasteners, and also if you have a look down in the bottom there is a spade connector, and that goes onto each of the brushes. Having a look down the center of the windings, specifically at where the bearing sits in the housing, there's a small round recess, and that's that bit over there. And something that I just realized that I noticed is when I pulled the armature out, it came out with no effort at all. So there was really no friction fit at all between the bearing's outer casing and this casing here. So something to keep in mind, that when your tool gets old and potentially that bearing maybe starts hanging up, starts rusting a little bit, the outer race of the bearing, that's this section over here, can actually start wearing out the housing, and sometimes it can wear out the housing so much that the that the armature touches in here. Now, it's not to say that it will happen with this or that it's happened with specifically blowers, but it does happen. And I mean, you can have these things for years and years and years. If I think back to the one that my dad's got, he's got one of the teal colored tools, and I think he must have had that for at least 15 years, and it's been working, you know, a fair amount over its lifetime. So, you know, keep that in mind if your tool is making some funny squirmily sounds or squealing sounds, or it's vibrating. It's possibly one of those bearings that is worn out, or maybe even the casing. And I suppose the last thing to look at is how sturdy is this half of the case. Now, if I try and squeeze it like this, it is really, really strong and sturdy. There's absolutely no flex in it, and that is a good thing. So that's just going to go to show how tough this case is. If I try and twist it like this, it doesn't really want to twist at all. So as I said, when I initially unboxed and reviewed it and we did the testing on it, it's definitely not a thing that's going to break if it falls off the table or gets thrown around a bit. One thing I forgot to point out was this little board. It's on the little speed control board here, and it is held into position in the clamshell by means of a little screw, a little fastener, and you can see that fastens into the center of the board. Now, I quite like that over the fact that they could have, I suppose, just indexed it into these little corners and jammed the board in between the two halves. So, I mean, we've seen that on a lot of tools, and I quite like that they've put a fastener in there. So, what did you guys think of the inside of this tool? I was a fair amount disappointed with the condition of the speed control board in here, but then again, maybe it is just one of those Friday tools, you know, beer o'clock time, get the job done just so we can get the weekend started. But let's not hop on the bad stuff. Let's just be thankful that this thing blows real good. Well, let us know in the comments what you thought. Give it a thumbs up if you liked the video. Subscribe if you haven't already. And we'll see you next time. Cheers.